I want to thank everyone for coming. My name is Tim Doherty. I'm the organizer of this meetup group. And first things first, I want to thank the Ownership for hosting us tonight. Randy stepped up and offered us the space, and we are very grateful for that. Thanks for the food, drinks, and everything. We are a group of JavaScript enthusiasts here in town, and we're also a open, inclusive community. We have enough passive-aggressive elitist people out there in the software engineering community, and we really want this to be a group where you can ask any question. We're all newbies at one time, and no question is out of bounds. We range in experience from people brand new to JavaScript, people that have been using it since it first came out. Let's get navigated to 1995. So we were all there before, and we want to share knowledge. We want to do it in a way that everybody wants. So that's who we are and what we do. And acknowledge our sponsors. So just acknowledge our sponsors. My employer, Agilicis, has been hosting us for a while now and providing food. We recently got WorkZone as a sponsor. That's giving us workspace downtown. You guys haven't been there. It's a really cool spot. Co-working, meeting rooms, things like that. If anyone's interested, I can get you a guest pass, so go check it out. But we're grateful for them. They're kind of our semi-permanent home now. And then we also have a partnership with O'Reilly Media. And we get book and video discounts, conference discounts. If we use the conference discount 3 times, we get a free conference pass. So if you're interested, there's a page on the meetup site that gives you all the details and the codes you need to get that stuff. Please use the conference discount so I get a free conference pass. I'll probably get a little bit. Upcoming events, we've got the end of next month, we've got keynotes. Keynotes we talk about HTML5 Canvas and the Canvas API, and that will be at WorkZone. In July, we've got Samir. Samir's here now, so we're talking about web workers. Should be cool. Probably also WorkZones. And then our August event is going to be about writing command line applications in Node. And it looks as if Pro course is probably going to host that one. Details to follow. I'll let you know. I think that's about it for the administrative stuff. So let's get into this. All right, moving on. I'm a software architect at Agilicis, going off here in town. I oversee the efforts of a couple of teams. Most of my team is in Bellevue. I mentioned I'm the organizer of Santa Barbara JavaScript. I'm also the vice president of Paradise Dashboard. What the hell does that have to do with JavaScript? Nothing. So that's what I like to do for fun. There's a great guy in out here at Channel Islands. Here's Matt. Come check me out. There's my links at the bottom. So what is Webpack? This is right from the Webpack side. Webpack is a module library. It takes modules with dependencies and generates static assets. What does that mean? Well, let's take a step back and talk about modules. So, those of you who are, who's not a JavaScript developer? There are a couple guys who are Webpack. So, modules are kind of core to just about every programming language out there. But they've been missing from JavaScript since its inception. We never had modules. They finally have Java. We'll talk about that in a couple of slides. But in the beginning, there was nothing. There was no way to modularly organize your code. You basically just had free-flowing scripts. So over the years, there's been various ways that people have tried to solve that problem. One of which is the immediate invoke function expression, which is basically you take a function, wrap it in an expression, and invoke it immediately, so you can string state, you don't leave things out in global state. Related to that, the JS module pattern and the revealing module pattern, we have object namespacing, where you basically create submodules by attaching a module to another object. And then script tag module. We've all seen that. Any non-trivial size JavaScript application might have 20 or 30 scripts all in them. And it's up to you as the developer to maintain the order of those scripts, because they get parsed and evaluated by parsed at runtime. All of which is pretty substantial. So then we got modules. Late 2005-ish, 2006-ish, we started to see ideas come around, and certainly when Node didn't see, the Node community adopted CommonJS, which is a synchronous file management definition. It doesn't work very well in browsers. That doesn't work for all browsers without some sort of a pre-processing step, and we're going to talk about that tonight. And then a guy, a Mozilla engineer by the name of James Berg, came up with something. He talked to the CommonJS folks. They tried to figure out how they could make one sort of specification that can work both synchronously on the file system as well as in browsers, but they just couldn't make ends meet. They couldn't stay online. And so we came up with this idea of the asynchronous module definition. It's designed to work in browsers, and basically what it does, it wraps your modules in functions that take an array of dependencies, typically file paths. And it works really well. And it also has a bundler called RJS. We'll talk about in a second. And then UMD is the hybrid code. UMD is basically some boilerplate code around a module that checks for the environment that's running. So it's in CommonJS environment, it does a module that exports CommonJS style syntax. If it finds the require API, it builds a require module. Then we got native modules. So last year, ECMAScript 2015, better known as ES6, was ratified by the TC39 committee. And with it, we finally got a native syntax for modules. And it's all agreed on, it's interoperable, it's statically analyzable. There's all sorts of really cool things about it. But the most important thing is that it gives us a common syntax for modules that'll work both in browsers and in synchronous environments. The problem is, the loader for browsers didn't make the cut. So they abandoned it late 2014, and they're basically rewriting it. So in the meantime, there's a reference implementation, the ES6 module loader, and there's a really cool library called system.js that's built on top of that. And there's a really cool bundler called JSPM that's built on top of system.js. And all this is really cool, but we still don't have a spec for modules in the browser. And it's probably going to be a few years before we can reasonably expect to see browsers out there in the wild implementing native module. So in the meantime, we got these things called module loaders, right? So we look at that first statement. Parsing and traversing is not that expensive, but in the browser, in an asynchronous environment, fetching the dependency tree is expensive, right? You got a bunch of asynchronous requests, but first, in order to determine what one module depends upon, you make a request for that module, you analyze its dependencies, you make an async request for its modules, and analyze their dependencies. And it gets prohibitively expensive, right? These HTTP requests are expensive. You can parallel them out, but most browsers cap it at about 6. So any more than 6, and you're blocking waiting for those 6. One of those 6 to finish. So, and also because of that, because HTTP requests are expensive, it's a best practice to minimize the number of them that you do to get your resources. And so for years now, we've been concatenating together JavaScript and CSS files and inline spriting images and things like that. Now, everything we've learned about that is going to change in the coming years now with HTTP2 on the horizon, where HTTP2 is full multiplex, which lets you go with a single HTTP connection and make all parallel requests you want. And so in a few years, here's what it will actually be, all this will go away. And so, bundlers like JSPM are on the forefront of that, and they're thinking more in terms of the actual runtime dependency traversal and fetching. But that's not what we're talking about tonight. So why Webpack? There's a bunch of bundlers out there. I mentioned RJS, RJS, Browserify, which is the first one to really become popular. JSPM I mentioned, there's Rollup, Dynapack, Glosso. If you go to search for module bundlers, there's quite a few out there. These first 3 are arguably the most popular and most relevant out there. So the main reason for Webpack, they do code splitting. Code splitting is not necessarily specific to Webpack, so RJS lets you do layered bundles as well. But Webpack has some really nice optimizations for it. Like it can traverse and find out if one of the 2 bundles share a dependency, then it split that out into a common chunk, so that only gets loaded once, right? You got a bunch of micro optimizations that you can do that improve speed. And then another really, and this is probably the most important feature of Webpack, is they have this concept of loaders. And loaders take things that are not JavaScript to turn them into JavaScript. We'll look at that when we get to loaders, but it's a really important concept, paradigm that it embraces. It lets you do expressions and dependencies, so you can build your dependencies based on calculations and things like that. It has a highly extensible plugin system. A lot of people think that Webpack is just sort of automagical out of the box and does everything out of the box, and it kind of does, but the core is actually fairly lean. Most of that functionality is enhanced by plugins. It also has top module replacement, which we'll talk about in a minute, but basically it's like live reload for individual modules. So any of you guys that do web development, you probably use something like live reload, where it wants your file system for changes, and when a file changes, it sends a signal to the value of the expression set. This is just like that, where instead of refreshing the page, it sends a request by WebSockets with just the contents of the module that's changed. And of course, the most important reason, all the cool kids. We all know about style and fashion and things. So let's talk about the basics of Webpack. And it's very basic. What it does, it takes an entry point or multiple entry points, traverses their dependency trees, and then produces one or more bundles. But all that stuff stuck together into a single action. Things you can do along the way, I mentioned loaders. You can do preloaders, loaders, and post-loaders that can transform those dependencies as they're loaded. You can do code splitting, which is asynchronous loading of bundles. And then we talked about plugins that can be used. Typically, plugins are used to work on the bundles once they've been produced. But those are the things you can do too, like clean your build directory out before you actually run the code. So it's very basics. You have an entry point. And all it does is log out and require another module. Then you have that module, JS, and you just run the command line Webpack, entry.js, and the output on the file. And what it produces is something like this. So we have this outer function, right? And in that function is the Webpack runtime. And we'll see when we look at the tutorial and look at the first step. Without any of the loaders and all the fluff that you could add to it, that runtime is incredibly simple. It's a really super simple little module loader. And then the input to that function is just an array of modules. And those modules are just functions, right? And interestingly enough, as you get in the internals here, when these guys actually, this returns a function called Webpack require, which is their module loader. And what's interesting about it is you can see that that's an array of functions. It actually references them by the array index. So they don't even have module names. So we saw that little command line interface. It turns out the command line interface is a pretty powerful tool, and you can do most of the things that you would want to do with Webpack from the command line. It's just that it gets a little clunky typing in all these commands. And so they offer a configuration file, makes your life a lot easier. And the main sections, and one of the reasons I tried to keep, when we look at the tutorial, I tried to keep this as simple as possible, because one of the things about Webpack is it's often used in conjunction with other technologies, like React, right? It's most commonly found alongside React. And that whole ecosystem of tools that surrounds it. And so often you go and look at Webpack examples, and you're not seeing how Webpack works. You're seeing how Webpack works with a whole bunch of other stuff on top of it. And so these config files can be sometimes incredibly complex to look at. But it turns out when you strip it down to its basics, it's pretty easy to understand. And then you build on it from there. And so at its very basic, it looks something like this. In fact, with just plain JavaScript, ES5 JavaScript, you don't even need the loader section down there or the plugin section. At its very basic, you define an entry point and an output, and that's it. And then instead of saying Webpack and telling it what the entry point is in the output bundle file, you just issue Webpack. So debugging, we got this big module, and we've all seen the concatenated, particularly minify files, right? And we've seen source maps and things like that. Well, they give you a bunch of different options of how to handle debugging. And what it comes down to essentially is a balance between how sweet do you want your debugging experience to be, and how fast do you want these things to be able to be rebundled. So at the very basic one, it's just eval. It literally just evals the module and spits out the source with the source URL. So it's mostly readable, but instead of like module.export or require, you get that Webpack require function and a few other like syntactic sugars that it gives you. The opposite end of that spectrum is source map, which actually emits the source map file. Right? That's going to give you the best debugging experience, but it's also a lot slower to generate, particularly if you're like watching files in the browser and reading or to reload. And then they have a variety of different other options. Inline source map is like source map, only instead of emitting a file, it adds that data URL inside the actual JavaScript file that contains the source map. And then you can combine some of these things. I'm not going to go into detail with all of them, just to give you a high level idea of what's available. So let's talk about loaders. We will do this. Okay. All right, so Webpack can only process JavaScript out of the box. Okay? And that's great. So JavaScript's already got modules, right? We now have native modules. We have all these modules. It turns out Webpack can recognize the first two, and potentially the third one. It doesn't, out of the box, yet recognize these modules, although Webpack 2 will. Webpack 2 will have native support for ES6 modules, which is really cool when you think about it first, because cool, I don't need to transpile those models, but it doesn't recognize any of the other ES6 syntax, so you're still going to need to transpile that back to actually read the code that's in your release. So what about the rest of the resources? Right? Most of us in this day and age use some sort of build tool. Who uses a build tool under JavaScript? I don't think more than that. What tools do you guys use? Well, run. Please run. It's pretty cool. It turns out with Webpack, in many scenarios, you can actually replace your build tool with Webpack. And it's mostly due to this concept of loaders. Okay? So when we look at something like grunt, don't use strings. So let's take grunt, use the file system. You tell grunt, here's a bunch of files, do something with them to create the files. Right? And then it proceeds to do that like file types. So Webpack takes a different approach. It says, all right, tell me about these things that aren't JavaScript. Do some processing and wrap them in JavaScript and just include them in function. And so it does that as part of the traversal of the dependency. It gives us a unified paradigm, because every asset in your code base is a model. There's always something to be said about unified paradigms. And so, like I said, you can actually, in most cases, you can at least partially replace your build tool. So, and it's very basic, and stripped down to its absolute basic, and this would be like an identity loader. It's just a function that takes it as a source, as a string or buffer, and returns it as a string or buffer. Now, it's what you do in here that transforms your output. And then what it produces in your Webpack bundle is something like that, just another function. It's really quite simple. But in reality, most of these things actually do something. So one of the really commonly used ones is CSS. Right? It's actually used in conjunction with the style loader. And what it does, the CSS loader reads from your file system, the CSS file, and creates a string. And then it puts a runtime. Basically, it requires itself, that function we saw before, when you were declaring that, you would import another module, which would be this runtime module that gets injected into your bundle. And its responsibility is to then insert style text dynamically in your document. Now, there's other ways to go about it. You can actually extract that CSS and have it be cacheable as a regular resource. But this is a really common loader. And then when you want to use it, by default, without any configuration, you just put the names of the loaders in front of your resource. And then you pipe them together with an exclamation point. You really don't, most of us don't really want to do that in our actual style sheets. We'd rather just do require style.css. And so you can actually configure it in your loader, in your Webpack config. You give it a regular expression and check what types of files it's using before it's loading, and then you can give it that array of loaders. And then you can also override them. So let's say, for most of these things, we want to load our style sheets using CSS and style loaders, but what if we're writing an Angular 2 component? We actually want to take our CSS as a string and inject it in the component declaration, or we can just override it with a double bang and use the raw. Raw just literally reads the file and returns the string that way. And then the other really common use for loaders, I mentioned React, is to transpile languages that transpile JS. Things like CoffeeScript, ES15, JSX, TypeScript, Elm. There's a list longer than I can rattle off here. Okay, plugins. So plugins basically are used to extend the core functionality. I'm trying to move fast through the slides here because we got a tutorial. I wouldn't be here until 10 o'clock. So like I said before, a lot of the built-in functionality of Webpack is actually provided by plugins. And it's things like minification with Webpack.js, duplication. I mentioned before, you have two chunks that have common dependencies. You can consolidate that common code. Chunk optimization, so then the really popular one is hot optimization. It's also a plugin. And basically what these are, they're just instance log with a define method. And inside there, you basically hook into the various phases that compile or expose. And then you can do things. Like here, we're grabbing the done phase. When Webpack has completed the build, we want to do something like, hey, we're done. Right? But the reality is you can hook it at the very beginning before it does anything. You can do it while it's traversing the module tree. You can do it right after it's finished with loading. And it basically makes the extensibility of the tool almost limitless. And then to install them, all you do is add a new instance of this plugin. Here's the most common. Okay, code splitting. Code splitting is just a fancy name for asynchronous dependency loading. And basically, this allows you for really large single-page applications where a user may take one of several paths through the application and may never use some of the code. You don't want to load it all up front, like you have to do in one, because it will boot without all the dependencies at one time. It'll get you started on that. But if you have something like Backbone or React or others that don't require that bootstrap phase at the very beginning, then you can just have that stuff lazy remote and later. And so these other module syntaxes, CommonJS and they both support this with different types of syntax, and they're both natively supported by Webpack. I mentioned Webpack 2 it being 6 modules. Webpack 2 will also recognize system.import. So system.import is part of the loader spec that never got ratified. But most of that content is pretty static at this point, though we should expect it to look a lot like what's been implemented already. So it doesn't actually use PES6 module loader implementation or system.js. It just recognizes this part of the spec, system.import. So you can define it using all three. And so here's a really simple contrived example. We have a button on our page. We grab it, we add an event listener, so when the user clicks on it, we want to lazily load some code. And so basically, this is using the CommonJS syntax. Require down short takes an array of the paths of the modules you want to load. The function gives you a require statement, and then you can do whatever you want with those dependencies. Development server. So they give you, doesn't come bundled with it, you have to install it separately. But they give you the Webpack dev server, which is an express-based node web server. And it has included in it some middleware that's built to load these modules. It also supports hot module replacement. They use internally like a records, an in-memory store of what the modules are and what their states are, and this includes an in-memory version for you. You can start it using the command line interface in a config file, or more popularly, there's an OAP for it that lets you do some nice things. And it automatically spawns file launchers, puts markup into your modules, and then watches your pages and all that refreshes. So without hot module replacement, the tier 2 options are, and I don't think I've ever seen you do this outcome, but you can actually spawn it in an iframe, and you get a little information bar at the top. We're not going to do that in the demo, and maybe because we're going to do hash changes, and you don't see much reflected because we're sitting in the iframe. The other way is just to do it in line. So inline flag, then that gives you just a regular browser experience. You see status updates at the bottom, you can change the hash fragments and things like that. Hot module replacement. This helpful diagram here should be self-explanatory. I know I looked at it, okay, I get it, hot module replacement. Right? Everybody gets that, right? Basically, it is a combination of markup or code that's added to your bundles when they're transpiled, and at a runtime, once you round to accept those updates. It's opt-in, so without doing anything, your modules will not hot replace. But it turns out that the API is fairly simple. We're going to do like a really simple, contrived example. But then, it bubbles up. So if a module doesn't have hot module replacement enabled, but its parent does, it's handled, and you can actually, in fact, just put a single handler at the very top of your dependency tree, and that will handle, it'll flow down. But the easier way to do it is just to use stuff that everyone else has written, right? Yourself or somebody else's. So like React has a hot module here that everybody uses. Okay, let's look at the code. Okay, I'm live coding here. I hate live coding, so it's really easy on me. But try to make this as big as possible. So this is, if anyone, I don't know if anyone got a chance to look at the tutorial, nobody's got a laptop open, so it's just me. Alright, so, like I said, and pardon my presentation, I like the term do not disturb on. So actually, the first couple of steps here actually were modified ever so slightly from one of the pages of the Webpack documentation. The Webpack documentation is a little hard to approach. And not because it's bad, it's just that, there's one guy who maintains it for the street level, and contributions are scarce, and the documentation is a little bit scattershot. Some of it's really concise and well written, and others just like scratch head. But there's one page in getting started that when you read it, top to bottom, actually really makes sense. And so I took a few little snippets from there and just went off and did it. And so basically what we have here, let me kill that one moment because we're going to make that. So basically, what we have, can everyone read the code there on the screen? Should I make it bigger? Is that readable? Yes. Yeah, very cool. So basically, all we have here is we have an entry file, and index.html, and then in our package documentation, we just have the Webpack dependency. Now, in real life, as I go through each of these, you would be running npm install some of these dependencies, but I really wanted to respect the bandwidth of Wi-Fi in case like other people were doing this as well. And also we're trying to stream this live. And so I just went ahead and installed all the dependencies beforehand. So So at some point, if I'm like stepping ahead, and wait, you didn't put the Webpack dev server in there, just remind me of something why. And so this is like a super bare bones, like the pretty much the simplest Webpack bundle you could create. You got one file, and we're going to bundle it. And the overhead from the bundle is going to be a lot more than the file itself. But in order to and so all we're going to do is we're going to put some markup on the page. That's it. And then index.html is just a single script file. It's going to serve up from .js, which doesn't exist yet because you didn't see it in the video. So we just issue Webpack entry.js, and then give the output file name. It'll do its magic, and then all of a sudden we get this beautiful looking bundle.js. So I mentioned before, I showed you that kind of really stripped down, showed you that really stripped down code. We just had a function that took an array of modules. This is the function, and then down here is our array of one module. And there's our module. Isn't it glorious? Look at it, it's beautiful. We just created a Webpack bundle. But what we have here, and it's really pretty dead simple. We have this function, takes an array of modules, and it returns this function, Webpack require, which takes a module away. And I mentioned earlier that module ID is actually just a one index in the array. That's all it is, right? And it says, it checks this installed modules, which is an object to see if it's already been created or evaluated. And if it has, just return the hash, right? Otherwise, it creates the C module object, right? And then it takes that function and does a call on it, passes it a few parameters, sets the loaded flag is true, and returns whatever that module exports. So what that means is that any of these other modules, they call Webpack require, and Webpack require gives them whatever that function returns. It's actually really simple, right? That code there is, I think, pretty easy to understand. When you put a CSS loader in there and the hot launch replacement runtime, a bunch of these others, that all of a sudden the runtime grows quite big. But when you get started like this, it's simple. And then we have this beautiful looking page. Right? Ship it. Good. All right, so the problem is that that's not a very useful bundle. Here's our source code, right here, this line. And what we ended up with 51 lines of code. That is not an optimization. So let's at least make it worthwhile. Let's add another file, and let's call it content.js. And here, let's export something. And actually, let's export what we're writing into the document here. Let's get this whole piece here, and let's make this other guy export that. All right, cool. And then instead of just writing to the document a string, let's require content. Actually, we don't need JS, we're using the default manager. It will recognize out of the box that anything with JS is not. You can tell it to recognize other things like that JSX. All right, so now two modules. One depends on the other. So let's run right back again. And now our bundle is 2 lines. So now we took 2 lines of source code and turned it into 58. Cool. And we should get exactly the same approach. Okay, now it kind of looks a little plain. Our page is kind of white. So let's give it a style. And with that style, let's give it a loader. And so actually, step 1 here, but I've already gone. So in package.json, as we go through these, like I said, I would begin installing, and what we would see next is CSS loader and the style. Just pretend that because they actually do exist in the other modules right here. So now let's create a style sheet, and let's give the body a color. What color? Black. Black? No, you won't be able to see the text very well. Come on. Dude, you apply it to size of my company. Come on. How about one of the well-known colors? Tan. Tan, huh? Okay, cool. Let's do that. Excellent. Now, let's run it again. Now, apparently doesn't like, we forgot something. We actually need to include that. So remember I said before, it only recognizes JavaScript, but with that loader, we can now import it just like any other resource, except we're going to have to specify the styles in line, or the loaders in line. So let's do this. It won't recognize that now. We now add style and CSS. Now, it should pick that up in the loader and recognize that there's some bundle. And now, we have this beautiful thing. Now, that's sexy. Good job. Color. There's a color. I like that. Okay, so that's a really simple loader. Now, I'm going to attempt to, I'm going to do it here. Any of you guys do Adam? Besides me? Anyone use Adam? Adam, I am Adam. Use Adam? There's a bug in Adam that has been open this a year, but it's fixed it. It does not deal well with large files, particularly large like unified files that expand, not files size-wise, but files that span many characters wide and reasonable. So instead, let's just look at it here real quick. Let's look at bundle, and what we're going to see in here, somewhere, where's the bundle? Where's the bundle? There we go. Okay, now if we look at this guy, all of a sudden now we've got a whole bunch more stuff in here. So at the very top, we've got our simple Webpack runtime, which we saw before. It's just that define that Webpack. But now we have a bunch of what these are as modules that have been inserted by the CSS. This is the runtime of the CSS style. And basically, the responsibility of these guys is to insert style tags and stick styles in the back. So, in fact, why don't we do this? If we now look at the document itself, if you look at the head, what we're going to see is the insert style tag for us. Go away. That's cool. Glad to ourselves. That's kind of cool. All right, so how about like images? How many people use images in Word? Some of you don't. Right? I was chatting with this year. Actually, Brad from Broco said, I think it's really great. You're holding up innovation. One of the guys did a talk the year before, and we kind of got a good laugh when we talked about UI innovation and crisis. Anyway, most of us use images, right? And one of the ways we've been taught to optimize image loading is to inline them when they're small. Right? So if it's below a certain size, we just create like a 60 board for the data. We have the image and just stick it right in the file. Cool, right? So there's a little image loader that actually does that really well. So let's change our color back to white. And I'm going to cheat. We're going to download this image from the tutorial. Let's see this guy. Let's see who he is. Very cool. We're going to save that guy. And actually, let's not go to the body. Let's create a class for our logo. And then background image, URL. What's that called? Webpack logo. But I can type it, really not. Okay, so we can go to background image. Cool. And then what we're going to do also, I skipped a step. Let me do that first. Let's do this. So in order to get this to work with the style, we actually had to put some funky little markup in there, style, CSS, etc. Let's get rid of that. First, let's do that. What we're going to do is we're going to tell it that we want to match any module that matches the extension that we get. Should use the column order. So we do module line, and then we say CSS equals style CSS. Yeah, and then not match. Oh, did I do wrong? Dash is so equals. CSS dash equals. Thank you. Arrows and line codes. Sorry about that. Come on, somebody's the Webpack expert. Come on, jump in here. Come on, Brett, save me. I'm drowning here. You know what?
History grab.
When all else fails, cheat. Oh, single bars. Let's try it. This didn't happen either.
How you save them?
Wait, what? That should be good. That should be good. That's what happened.
Yeah, the PNG.
You didn't say you only set the character in your CSS?
Yeah, the image.
What's wrong with that?
You have the PNG loader in your Webpack example.
Oh. Yeah, good point. Nothing's actually using that, but yes, that's exactly what it is. Thank you. Gold star, who said that? All right, that worked. Thank you. Cool. So now we start out, we changed our style away, but anyway, it loads the CSS without all that funky inline mark. Okay, now, so now where I was going before I realized I could just completely skip this step, is that to load the ping file as well, we would need to bind another module command line. It's just a lot easier to add a config file. So let's do that. .com.js. And what that looks like is we're just going to do a good old-fashioned common.js module that exports. And it's going to export an object. And we're going to give it an entry point. The entry point is entry.js. And then we're going to give it an output. And that's going to be an object. That. And tag is definitely not going to work. And we're going to go find, and it's going to be bundle.js. And then the magic comes here. We're going to find how to deal with modules. And what we want is loaders. Loaders is an array. And here we're going to have two of them. First one is going to be our CSS loader. That's one regular expression. CSS, CSS. And then the loader is going to be actually two loaders, pipes, which are style and CSS. And then the one we want is our ping loader. So let's do test. Ping. And this guy is going to use your loader. Okay, now we need to use that. We need to use that class to make some service. We're going to do and what do we call it? What's on it? Yeah. Okay. Now, we should be able to just run the Webpack to the config file. No programming variables. And it worked. Load it.
Comments out.
Oh, yeah.
Which the CSS? Did I have a comment?
All right.
Oh yeah, your div has that with paint not show.
Yep, you're absolutely right. And let's find out what that is. 497 by 270. Ship it. So, what's cool about that is that we're going to check out the resources in here. And we'll have something. Just reload it with that bundle. But in here, somewhere, right there, is a base 64 code image. Cool, right? So you can actually configure that in order to have threshold. which point it just will fall over. It actually has a peer dependency on file address, which does just what you should rows of files. And so you can configure it until the threshold below which it should actually inline images. Everything else just stands up in the file. Rows of file. It's pretty cool. All right, what's next? I have to remind myself. I'm 45, and I can't tell if it's like I'm getting more serene as I get older or more senile. But I can remember things with perfect clarity that I did 30 years ago, but I can't remember what I did 5 minutes ago. So bear with me. All right, cool. So we got our image order. Okay, cool. All right, so let's do this. Let's create a new file, and let's call it split content. And in here, let's just do something like, let's add something for the way to first. Let's do that. Let's add a new div here. And let's call it cool. Now we can write something else. Let's do that. Career selector. Stop. Sure. Oh, everybody can do it. Alright, cool. Nope. Okay, cool.
Content.
Split content. Split content? Let's spell this one. Yeah, that's it. Cool. Hey, but it worked.
Yeah.
Nobody, the client would never know. They just say, make it pop. All right, so now we need to actually do something with that, right? So what we're going to do is, let's do something like this. We've got that. Let's make a 4-man router. We just have a 4-man router. You guys are all using like Angular UI router and React router and stuff like that, right? Does anyone know how to make a 4-man router?
Hash.
Yeah. That's adding an event listener. And this is not fully implemented in all browsers, Internet Explorer, but it's pretty readily available in modern browsers. Basically, we should have an event listener and hash change, and let's make some routes. So let's do routes. And we have, where are we got home and about. About actually has something. So let's make this key about, not that, also about. And let's give it a function. And let's also have like a default route handler, shall we? And we know how to make it, we know how to make a no function without actually letting the function incur the records. Not all that stuff. That's not what I wanted. There we go. Function prototype is null by default. So if you ever been to like, if you're testing something out and you don't want to actually implement your failure callback or something like that, just go function prototype. Of course, now with ES6, you get those nice little functions, which is probably less characters in function prototype. It's still kind of cool. All right, so when this happens, we want to do, we're going to use common.js syntax to do prior definition. And we want to pass it an array, and in that array, we're going to load its split content. And then it gives us a callback function that takes required. And inside there, we're just going to require split content. Okay, cool. Now, should work, right? Are we missing anything? All right, so what should happen now, when we load this, actually, we that over. When we load this, let's bundle it first. Okay, bundle work. Now when we load it, we'll get bundled, right? Now, what's going to happen when we click that? No one? Bueller?
I would guess. The content from the split content will be loaded into
Nothing. Nothing. What do you want? Sure.
Can you explain what you typed in there in the function?
Absolutely. So we have the outer hash change function. It's listening for a hash change. I I know what's wrong. Thank you for pointing that out. This is not complete. We defined our routes, but we didn't tell what to do with it. We just have this object and routes it. We can do something. Let's create an action table, and let's say our is going to be routes. We know about location hash, which is going to be the hash right in the browser. Or if that doesn't actually do anything, we'll do a step default. Right? So now at that point, we're going to say, is there an object?
You just have to route.
Routes within it.
Thank you. All right. So we're going to look for a key in our routes object that matches the current real location hash. If that ends up being null or undefined, we'll just use our function object that should be actually null. And then we just need to look back. Okay. Okay, so let me. Okay, let's try it now. Come on, you guys. Oh, it should work. There it is. But I was waiting for bundle one, not bundle two. Let's refresh that so we can see it. Can we slow it? All right, so when we first start, we just get bundle guys. We click this guy, and we get an async request for one, not bundle two. And all that guy has in it is the contents of our set content module. And you see also this Webpack JSON that doesn't use the JSON request. Everyone knows what JSON is?
JSON pattern.
JSON pattern. Is anyone not familiar with JSON?
Yeah.
Okay. JSON is no longer used all that much. It's a way of getting around the same origin constraint browsers. So by default, browsers will only load scripts from the same URL, same domain, which they will load. We since have tools like Core's cross-origin resource sharing that allows us to make actual full-fledged HTTP requests, but folks have to make also do that. The way JSON works essentially is it takes advantage of the fact that you can load a script from anywhere. Scripts don't have same constraint calls, right? That's why you can use scripts from the CDN, things like that. And what it does is it requests a resource and it passes with it the name of a function in your local context is a callback. And what the resource on the other end does is executes whatever it's going to do and sends back the request wrapped in that function. And so your local context then can evaluate that function and get the results back. There's some security vulnerabilities with it, and it only works with GANs. So you can't do a post or any of the other HTTP codes. But it's useful in certain cases. Okay, so that's split code split. Any questions on code split? If they understood that right, it's pretty simple.
So you ensure, make sure that content is loaded in the browser and then you require it to execute it.
So required ensure is actually a ConJS construct for asynchronous loading on the processing, and this gets translated as part of the Webpack runtime using Webpack JSON. And so basically what it does is it says, when it encounters one of these things, the bundler actually says, okay, treat this as separate content. And so it creates a separate bundle process, separate script process. And then when your code actually hits this, it actually hits Webpack JSON, which you can see right here. When your code hits this, Webpack then will actually load that separate bundle from the process over XHR of the process. Make sense?
I think so.
So this syntax gets transformed. This is actually a syntax that is not Webpack. And this won't run in the browser by itself. This is common to this syntax.
So is it easy to switch from, let's say, development mode to production mode? So I guess now it's loading it from your laptop, but when you put that in production mode, it's not good. Absolutely, I mean, these are just files, right? So, what I did first, actually, I opened that big file, not the others. If we're lucky, it'll like wait for a minute, and then it'll say, keep waiting, or we'll give it a keep waiting and see if it returns and what. So, that's really my only complaint with Adam. Adam is an amazing provider. It's built into Electron, which is it's a node-based, node and Chromium in the same thread. And it lets you have basically node and everything you do in the browser, and so you can build complete desktop applications. The other one came out recently was VS Code. Let's keep waiting and see the responses. But basically it's hackable, right? You can actually open dev tools from here. You can write extensions for it. You can do all kinds of cool things. Very cool. All right, good. It worked. All right, cool.
kind of small enough you kill it. So basically, yeah, to answer your question, it just produces files, right? And so in this case, all you really need to do at this point is include one level on your page, right? And then the Webpack runtime will take care of loading one level. Now, you can even do cool things like when you run the Webpack dev server, we're not going to use this index like because it actually generates context for you. But what you can actually do is plugins that will let you specify a template. Like, so if you have proprietary markup or other scripts that you load from the CDN, things like that, you can basically have a template. And then using that plugin, you can have it auto-generate those script tags for you for all the bundles, all the output bundles that it generates. And you can even do things like when it creates those chunks, it creates a content hash, like a shop is hash. And so you can have it name the file with the hash of the file, so you get built-in hash. And it will automatically insert that script tag with the hash. So that's one thing that, like, I've been looking at JSPM too. Looking at JSPM does not support that box. It doesn't do cache posting. There's ways around it. And it has really cool bundle optimization, but it doesn't do cache posting. Okay, cool. So,
I have one question, sorry.
Yeah.
So would the main benefit of like code splitting then be like reduce overall file size?
it's to reduce the initial
files,
right? And also potentially to not ever load portions of the application, right? So if you have like have a large single page application that has, depending on your role, you go various different ways through the application. If you're an accountant, you may never deal with accounts receivable, right? Or you may never deal with HR, things like that. I'm going to give you like a really broad example. But there's plenty of examples where, depending on which actions you take different paths through a single page application. And so you can potentially just leave a single process and never plug up the network, and more importantly, make the user's initial load time quick. And it also is really important for multi-page applications. So if you have one code base that spans multiple pages, you can create like one common chunk that all the pages use, that only gets loaded once, and then it's cached and available in the user's browser cache for every subsequent page load. And then those other bundles represent only the content that's needed for each page. Right? So it lets you do actually some really sophisticated splitting. But the asynchronous stuff in particular is good for single page applications, where you only really need that code if the user take some specific action, and only then you really need it. All right, I think next thing up is dev server. Okay, so normally here I would do npm install Webpack dev server that's already there. And basically, what the Webpack dev server does gives you a couple of things. Like I said, it actually gets rid of the need to have this HTML file because it generates it in memory. And then it does the bundle, and it actually keeps the entire bundle in memory. It doesn't actually go back to the process. And then it inserts watchers into the source file. It watches that, all the bundles in memory, and it will do automatic refresh and code and things change. So, with that said, let's, I don't think anything else we can think of. That certainly helps just go spin it right up and let it work. So, let's do that. And we get the inline flag. Remember before I talked about two different ways you could view it. One was in an iframe, you just run right back that server. But since we actually want to watch hash events, we're going to do this. So we'll run it inline. It's going to do the thing that it normally does, right? There it is. And now we've got a regular default port, which is 8080. Which, interesting enough, I think that features up there, so let's go that. And we should get pretty much the same thing. So there it is. The cool thing about this now is we can change the rules to the content file. Let's put wait a second, it'll just reload it. And it does that using socket.io. Socket.io is a code-based WebSockets library. And then the inline flag injects the WebSockets line into the browser.
So it only detects the module that's had the changes and then sends that one that doesn't reload it.
Not in this case, it reloads the entire page. You need hot module fixing. It's coming, go ahead. No, this basically watches all your files. If anything changes, it just basically, actually, hot module fixing hasn't even been specified as anything. So at this point, it just says something's changed in the rest of the page. This is what most of us are probably used to, something like library load. I know my team is this, all of my teams are using this. We have library load, we watch the files, and you tell them how to watch. So not very exciting, but it works nonetheless. So the other thing you can do, instead of having to type Webpack dev server -- inline every time, everyone's familiar with npm scripts. Who's not familiar with npm scripts? Okay, so it turns out that, cool. All right, so everyone's familiar with npm, right? Is anyone not familiar with npm? It's only like the largest module repository in the history of software development. Kind of important. So it turns out that the NPM client is not just useful for installing NPM modules, which is its primary function. It's also kind of a cool little command line tool that does all sorts of really neat things. One of those things is it can actually run scripts for you. And by default, they give you a few aliases like test and star and things like that. But you can define anything you want. And in that, you have access to the current executing node instance with all of the node modules that are installed. So you can just alias them directly because you require modules. You can also have it run bash scripts for you. Turns out you can actually do away with the entire build tool and just use NPM scripts. I'm actually kind of thinking about moving that way at work because Grunt is really cool, but it's almost like an unnecessary abstraction on top of a bunch of node modules. Yeah, it gives you some nice configuration shortcuts, but do we really need all that? It's like, it's a lot of weight, right? We have a bunch of teams using it, a bunch of duplicating things, and we consolidated some of that. But it kind of just have to. So what we're going to do, instead of having to take that out of the time, we're going to go to package like this, and we're going to add a new script, and we're going to use this one to get out of the box to start, the alias is out of the box, and we're going to put that stuff in there. We're going to have server, and now we just have to get into the start. Just a little bit easy, straightforward. So cool. So we'll have that place on the next thing, which is hot module replacement. Okay, so we talked about hot module replacement. We were just one step ahead of it. Hot module replacement does a couple of things. It serves a runtime into the bundle itself that can listen for hot module events that get sent from the server. It puts middleware in the Express server to actually trigger those events. So it watches all your modules, and then it only sends out a packet that has the module that's changed. It sends it over WebSockets. And as long as one or more modules in a hierarchy of dependencies can accept that change, it'll substitute out for you without having to reload the page. And so it keeps bubbling up the tree until something that can handle it is found. And if it gets all the way to the top of the tree and there's nothing that handles that module replacement, it does the fall and just replaces, refreshes the whole page. And it turns out that it's unbelievably easy to make hot module replacement work for your modules. The only reason I probably wouldn't do it in my code base is because I don't want to tie myself to a build tool in my source code. And all you do though is you say if module.hot, accept. That's it. There's more to it. There's more sophisticated things you can do, and you can actually, from your code, you can hold the server and ask it if there's been staged and ready to go, things like that. But for the vast majority of use cases, all you really care is to accept it. Now, you may want to do something like conditionally accept the module change, or like that, depending on the user's actions. But this is like the absolute simplest way to do it. And so the one thing you need to do to make that work is you need to pass a flag to the dev server. That flag is, anyone want to guess? That's all right. I was counting too, right? So now, if you run that, you got a page, okay, everything's good, we've got a lazily loaded bundle there. Now, let's change the lazily loaded bundle and watch hot module replacement in action. Let's say we do document.body.endchild, and let's give it a document element. And let's give it something simple like horizontal. Now, if I save this, what we should see is let's get this third console. We should see some hot module stuff happening here. Never mind that uncalled syntax. It's actually going to be an extension. Now, if we save this, what we should see is, okay. Recompiling, checking for updates. See that? That little thing appeared there, horizontal roll right here, without refreshing the page. We'll also do something like alert. When we save it, recompile, we get an alert without refreshing the page. So that's
You got 2 HRs.
we do. Why? Why do we have to?
Because you didn't refresh the page and it just looked like an improvement.
That's right. Sorry. Yeah. Didn't refresh the page. All it did was replace the module, right? So this is item button. Right. Everyone knows the item button. Is do the same thing, you should get the same result. So, this guy, we have a DOM element that did, and we're replacing it with HTML, so this won't change, but we already had on the page in HR, right? And what we did is we replaced this module, so basically it said, here's the new module, now run it. When it runs it, okay, I'll replace this, but that's not going to change anything on the page. There already was a horizontal rule, and here I'm saying now append the number to the body. So if we change this again, we should expect the other, et cetera, ad nauseam. That's hot module replacement. That's actually really, really powerful, right? If your code base can accept hot modules, this can dramatically speed up your development process, right? Because even with something like run to develop, that will do over the library. There's pre-processing that happens, and then you put a browser. And it may only be half a second each time, or a second each time, but as developers sitting there all day tweaking your code, that can add up. This is actually, I think it's an amazing optimization. I'm steering my teams at work away from Bower. You guys all familiar with Bower? Bower's fallen out of favor. It's so much so that publishers are going to stop publishing packages in the Bower industry, like Lodash and things like that. And basically, because of the rise of module bundlers, people are going to use a single dependency for front-end stuff. And since most things are being published anyway, we already have module bundlers like Webpack and browsers on JSPM. Your Bower doesn't really serve the need that one's very effectively did. We're heavily invested in Bower, and I've had some on the radar for a while. Initially, it was because I wanted to get rid of having both NPM installs and Bower installs through our entire build platform. And then it was like, oh, Bower's going away. They're looking for maintainers to stop publishing things. And so now we're trying to push for one of these things. And so I would love to be able to sell my team a module replacement, but we can't, because you can't do it with Engine 1. I know all you guys here at Engine 1, you can't do it with Engine 1, because Engine 1 has this really peculiar bootstrap phase where it requires all of its dependencies to be available to the injector at the time the application starts. Now, just a real quick tangent. There are ways around that. You can load things like services. You basically have to hijack the providers when the application starts and save instances of the getter that the provider gives you, and then you can do lazy loading, but it's complicated, it's not officially supported, and so we chose not to go that direction. And Year 2 potentially solves it, because it does have all component level and service level injectors, but that's another grind of mine about Angular 2. I don't think you need dependency injectors. I think it's totally overcomplicates a problem that doesn't really need to be solved in the system. If you want to know more about my feelings about that, talk to you. But anyway, for those people who aren't using Angular 1, hot module replacement is really powerful. It's very, very important. Okay, so we see code splitting, we see hot module replacement, plugins. We haven't looked at plugins yet. So probably the most common plugin that people use, we talked about bundling, we talked about concatenating. How many people minify the code? Obfuscator. Right? Why do we obfuscate or minify code? Who wants to tell me why?
Smaller size.
Smaller. Obfuscating it doesn't matter, because most browser dev tools will beautify it for you anyways. And even if you mangle the names of your variables, smart enough people can reverse engineer. Basically, you have to assume if you're writing JavaScript that your code is visible to everybody. So I still have a hard time with my CTO, and this doesn't replicate. We have proprietary code. Well, really? It's a reference station. Anything running there, somebody can recreate, even if it couldn't see your source code. So the main reason we do it is to reduce the overhead of the actual request, right? So we can take a bunch of items from small items. So it's commonly accepted practice. And in terms of casual casual observers, sort of code, so I can't read that. Anyway, this uses, it comes with a built-in or a bundled JS plugin. So let's add that to our Webpack config. So on a new section called plugins. And actually, before we even include it, we're going to need to get Webpack. Because it is attached to Webpack object. So, remember I talked before about plugins. They're instances. So what we'll actually do is use Webpack. And we're going to give it a couple of options because we really don't want to see nasty messages coming out things that we don't care about. So we're going to tell it to ignore one. When it's trying to compress the files, it finds things that it doesn't like. Without this, it'll spew out some stuff. And still build the bundle of everything one. Just hold on. So at that point, this is basically going to say, all right, once it's done traversing the dependency tree, it's loaded all the modules and created the bundles, it will now run on process and whatever things you specify for it. So before we run that, let's look and see what the bundle looks like right now. Look at the bundle right now. It's pretty readable, right? That's the one bundle which I'm doing. If we look at this bundle right now, everything's good, right? We can read that, no problem. These guys, you may be wondering what these guys are. These are the hot things. So it actually does send files, sends resources. So anyway, right now it's readable. So let's run again. Let's kill that, restart it. We bundle it. And now we should see, cool, right? The problem is we can't see the source code file. So what we really need in there is something to give us a map. So I talked about DevTool. The one they recommend for development, because it's the fastest, is eval. And eval does just goes down to it evals the module, attaches the source URL to the spot bundle where the module was, so you can see what it looks like. But it's not optimal. It works. Now we're actually going to get mapping for individual files. But we get stuff like, which looks pretty good. Or here we get this Webpack required. It's not easy to tell that we're actually requiring the style sheet there. It works. Not optimal. I prefer something like the source map, which doesn't actually emit files to the file system, but gives us a data URL and gives us a proper source map. And then we can actually see the variables the way they originally intended to appear, which just makes it probably a little easier. And it's still pretty fast. Right, so now it looks like we originally did. Now, if you're using things like React or ES315 or CoffeeScript or Elm or things like that, there's one other thing you need to do, and that's add. There's a source map plugin. And the source map plugin will actually read the source maps that are emitted by those loaders and merge them right back. Because what happens is I found this doing an A2 PLC. Some of the source map supports really good drafters. And all of a sudden I was finding weird breakpoints and I couldn't get to stop certain points, and I finally discovered this on some Stack Overflow discussion. And it turns out that if you expose the ES315 source maps to Webpack, you get the purpose. Okay, so any questions on plugins? And there's a bunch of them. There's a deduplication plugin, which will analyze your entire bundle. And let's say you have a bunch of imports, you have nested stuff in your module directories, and two of them actually require the exact same module. It'll just go through and deduplicate them, pull them out so your bundle is smaller. I mentioned the commons plugin, which will, by default, it will look at two or more bundles as entry points. It'll look for ones that are shared by both and stick them into a separate bundle. But you can also configure that yourself. And that's what I've done with the things I've done so far, is you can actually specify another bundle, which is like all your third-party dependencies. You create like a vendor stuff, with the vendors file, have it require all the Angular and jQuery and Lodash and just Angular and all that stuff like that. And it will create the common string as all your third-party dependencies explicitly. And so those are out of your main entry points and also can be shared across pages, stuff like that. Cool.
Sorry, can I get the plugins from their GitHub?
The plugins, a lot of these plugins, like so anything attached to Webpack is included. There's a bunch of them. We're looking here, let's go Webpack. There's a bunch of them that are included. In fact, as I was saying in the slideshow, a lot of what Webpack provides out of the box is actually not the core compiler itself, it's plugins. If we go to Webpack here, there is in the lib directory, there's a bunch of, so there's Optimize, which is where the Amplify.js plugin is right here. And then there's a bunch at the root level, and there's a bunch of plugins spread throughout here. The Commons plugin, the DU plugin, things like that. There's a whole bunch of stuff that's listed on the documentation Webpack page. A bunch of stuff comes bundled with it, you just have to know what to include. And then there's a whole bunch of stuff in the community as well, which you can install from in here. So, yeah. All right, cool. Let's do this. Let's add some nice ES code and transpile code. Everyone's familiar with ES315? Anybody not familiar with this? Okay, so the JavaScript language has been around since 1995, and until recently, the last major update of the language was 20 years ago. It was just shy of that. I guess it was 1999. They introduced the third version of the language. It was a big update at the time, and then basically it sat for 16 years. And in that time, they tried to make a fourth version of the language, but the members of the TC39 committee couldn't agree on what that should be. One side of the committee had this really ambitious idea for basically morphing the language into, in many ways, what ES6 is today, and the other faction said, no, that's way too ambitious, we're going to break the web, and they just could not agree. And they eventually met on the committee meetings in Europe, and they, the two parties extended an olive branch, shook hands, and came to harmony, and announced this next version of the language, which was originally called Harmony. And it ended up as ES5, which dropped in 2009, and was actually a really modest, I think, language. It gave us some really important things, some reflective meta-programming tools around objects. It gave us some important array methods, things from functional programming, like add and reduce, and stuff like that. It was an important update, but just far narrower in scope than what was originally explored. And then that same meeting resulted in the ES Harmony or ES Next movement. They decided to start revisiting some of the things we explored, and you're talking about a really broad scale update to the language, which was finally ratified last June, and it's a monumental update to the language. It includes proxies for basically mapping objects and creating security membranes. It includes generators, which are pausable functions. It includes proper iterators, so we can do evaluation of collections without having to know the size ahead of time. A whole bunch of syntax advancements aimed at reducing boilerplate. It's a huge update to the language, and because it takes a while for browser manufacturers to actually roll out a new specification, it's a lot better now than it was in 2009 when ES5 dropped, because we still had an IE having major versions that took years, right? Even Chrome and Firefox were still on these number of versions at that time. In the ensuing 6 years, we've seen most browsers that are never being on where they're constantly updating, and that makes it easier for them to drop incremental upgrades. And so, building on that, the committee now has moved to a yearly incremental model where they're going to drop just a few updates every year. And ES6 is huge. And even just now, the browsers at the forefront of that, who wants to guess what the best browser, most compliant browser is leading the pack right now for ES6? Edge. That's right. Microsoft is finally making amendments for years of ES6. They say they're sorry about it, and I actually don't believe in some of the stuff. But it's just now we're getting to the point where the tool stack is being implemented in cutting-edge browsers. But until that, we've been using transpilers, which take one syntax, create an abstract syntax tree, and turn an output another syntax. And these first became popular languages like CoffeeScript. And that CoffeeScript heavily influenced the design of ES6. And so for years now, while the spec has been underway and proposals have made it through the various stages of the committee, people have been using transpilers, starting with one from Google, Tracer, which was the leader of the pack, until this whiz kid from Australia named Sebastian Kennedy in his dorm room in high school, I think he was, not even in college yet, came up with that whole, and overnight it just became this monumentally successful project, which everybody's using, except the English. They're still using Tracer. But Babel is by far the go-to transpiler, and so we're going to look at an example of using the syntax ES15. And the transpiler takes that, runs it through an abstract syntax tree, and outputs ES5, which every browser out there will run today. If you're adventurous and you have a modern browser, you can just write ES6, and most of it can run. The current version of Chrome runs 90% of the stack. But most of us in production have target old browsers. You can't run the rest of the 70 minutes, right? In a while. So I'm going to cheat a little bit with this one. Now what time is it now? It's not too bad. I'm going to cheat a little bit. Like, I'm not going to retype. I don't know Latin, so I'm not going to retype all this Latin. If anyone knows Latin and wants to type this, it's not bad. But so it's just a little warm. I thought about using the Samuel Jackson engine generator, so I wasn't sure. You guys seen that? You guys seen that? Like, everyone knows Laura can write for a place on the top. So the Samuel Jackson engine generator, you ask it to generate 3 or 4 paragraphs. It says, what is this motherfucker in my house right now? I didn't come here with a fucking coffee to you. You can't use it anymore. Go check it out. Check out the CD. So we're gonna keep it. Okay, we'll just add a file, I'll call it Lauren, so we, Lauren dashes. JS. And in here, we're just going to do a big couple of exports. And here, this is different syntax. We've been looking, we saw module.exports in our other module. So I mentioned at the very beginning of the slideshow that as part of the 2016, there's finally a native module syntax. And it looks like this. Instead of saying module.export, we're going to use the export syntax. So we're going to export, we finally get block scoped variables in 2016. Other languages have had for decades. Const, despite its name, is actually not a constant. It's only a signability that's constant. The data itself is mutable. Anyway, we're going to export these things, and their tables then be available. We import them from this module. We're going to import P1, P2, P3, P4. So that's what we're doing. So there's our ORM picture. So let's go to our content. And now, the other really cool syntactical thing that you get with ES2015 is templating literals. Template literals is a really cool thing that lets you have multi-line strings with interpolated expressions. It's kind of like a template. It's not quite by itself. By itself, it's really just string interpolation. They do give you a really cool feature called tags, tag functions, or tag templates that let you pre-process the template literal and do things with it, in which case you push template. So let's do this. Let's do a document .write first, and put some basic stuff out on the screen. We have like some of this header stuff. Actually, this cool guy. So here, say the stores. So now we can do free form, multi-line strings, which is kind of cool. And we can also stick stuff in there to do. Let's just call this content. And let's write the whole thing and continue it. We'll do that first. Okay, so this little backtick syntax means template string. We didn't put anything in it yet. The nice thing is we don't have to escape any characters. We can have white space and all that kind of cool stuff. There's actually an argument between your JavaScript will let you have the strings can be single or double quotes, and it's really up to a team where their style guide is. This kind of reduces that ambiguity. You check the levels everywhere, and part of the string escapes, things like that. But let's create some default content, not content. Content. So let's do const, and then make this a template literal as well. And in there, let's put like some of our alarm issues. So first, let's do a horizontal over here. And then, okay. So our default content, let's give it a header. And call it. Okay. And let's move our logo. And then let's put some let's get our arguments in first. Let's do import. And then this is another really cool syntax thing we get from ES6, which is called destructuring. Destructuring basically lets you pull apart objects or arrays, do really cool things with them. And it's sort of, you can use it basically to declare variables at the same time you pull contents out of something. So we're going to import P1, P2, P3, and P4 from Okay, so that basically creates in our local context variables P1, P2, P3, P4. Those are the exponents in that module. And now we're going to stick them in here. Let's create the tag. And then the syntax for interpolating is just $sign and curly brackets. So we'll put P1, and then we'll just keep that. Four, okay, cool. Now, it should all be good. Let's get the name. Last thing we're going to do is we're we want to interpolate that, we're going to put the default content in here, is going to be our contents. So by default should show us this H1, Webpack, navigating bundle bundler, the logo, and some more. Oh, let's also, let's see this inside.
Classification, or
It's,
Yeah, we're going to create that.
yeah, it's clean.
That's right, isn't it?
Some
It's what?
IPS.
No, right. This one.
It's fine.
Thank you. Okay, let's go ahead and create. I just want to basically make sure that's left line. Notice that everything is central. There's center line. Yeah. So let's go next to last. Cool. Yeah, looks like how it.
Yeah.
Okay. The place where you have to find
Involved in
cut it out. Did that?
Yeah.
Thank you. Thank you very much. You should do that too. Okay, let's also create a main here. Cool. Now, sound good? All right. Now, let's look at this guy. All right, so what we're going to do is we're going to create a render function. So that when we do the lazy loading, what we can render it out. Rather than doing a document.write or attaching something to it there. So let's create here. And send it over as well. Now grab Lauren guys as well. Let's grab all paragraphs here. And let's give it its own style sheet here. We'll meet with let's come down. We'll break back up. All right, so in here, let's do something different. Let's have another each one. And let's get another picture. I just so happen to have a little here. So let's make another div and we'll create a class in that style sheet we just referenced that we haven't created yet. So how's that a little bit? And then let's create some keys. Cool. Right, let's see the style sheet. The class called what is. It really worked out what I can tell you. That's what I get for saving videos like this. Sorry.